I got it all back together, new bearings in this. Over. Sounds like a little piston engine. There's one of them making some clatter. I got the alternator hooked up, just 6 coils of the 8 hooked up. I got the volts climbing now. I have the alternate transformer in series to the L3 line, as I've been talking about a lot. So it's a vector transformer. And the secondary, the 3.5 ohm side, goes into a full wave bridge rectifier right here. And that charges this battery, and this super cap bank all in parallel. So it's a gigantic battery and super cap bank, relatively gigantic. So I have this charging, and I have the alternator through this nice, very fast diodes full wave bridge rectifier, because this is going 240 hertz, and this is also being pumped in, the DC out. So AC, of course, coming out of it, and then the DC goes in. Let's see if it keeps going up. Yeah, it's still going up. Not too bad. I'm running off an inverter right here. I bet you it's going to reach a peak level of voltage, and it'll stop climbing, and then it'll start dipping down slowly. And then when it gets down to about this level, 12.4, it'll start climbing slowly. So there's kind of a slow cycle going on. Drawing from the inverter, the AC 120 volts, I think it's actually 116 volts. It is drawing AC amps about 150 milliamps. So I don't know, about 14-15 watts or so. This is taking to spin this thing. If I just spin the alternator and don't have all this charging stuff hooked up, of course, again, it's always a 4 US cap with this. If I don't have the charging stuff hooked up, and just spin the alternator with no load, it's 80 milliamps, 0.08 here. And if I just run the rotovertor with nothing on the shaft, it's 0.06, 05, right around there. So it's about 5 times 12. It's about 6 watts to run this. And about 10 watts, 9 or 10 watts to spin this. So this adds about, just to spin it, it adds about, I don't know, whatever that is, 3 or 4 watts. So this is a nice efficient alternator. It doesn't take much to spin it. And now when I have the series cap charging what the motor's running on, it goes up to 150 milliamps. So what do we got now? 12.49. There, it's still going up. Not bad. What I did was I tightened the air gap of this. It's not such a wide air gap. I made it more narrow. Also, it's making AC for sure. The magnets, this magnet hits, then this magnet hits. Like north, and then north, and then north, and then north. So it makes AC. It's hitting alternating ends of the coils. So, still going up. Now what this could mean is that the one of these batteries has a lot of juice in it, so it's trying all three, the super cap and the 2 batteries, they're trying to kind of equalize each other. Why it is climbing. It was not climbing at all, it was dropping a little bit as before until I hooked up the alternator to have that being charging too. I'm going to wait for this to go up to 12.58. There it goes. So this is not bad at all. I would say it's a successful loop. Now I have a coil up here and a coil down here that's not being used. And I'd like to add those to what comes out of the full wave bridge rectifier hooked to the alternator output right here. So I think that'll be my next project. You know what I'd like to do is see if I can get that 20 UF cap between here and here. If I can get that to work where it lowers the draw while it raises the output. So just a minute, I'm going to try that. Well. It made like a big magnetic break when I did it, when I added this. You know what? Yeah, so my fail-safe taped coupling failed safely. And you know what I think? I think I need to have this cap filled up when I do it. I bet you this cap was at 0. Bet you that's what happened. But when I plugged this in, it just went donk. Just stopped immediately. So I guess that's good enough for today. Thanks for watching.